to the presentation.
Yes, so for another minute and we will start. We will just short introduction
Okay.
and then recorded presentation will be there.
Yeah.
And
Yeah.
after your presentation, then there will be a live question answers.
Okay,
Okay.
because I'm also held up in other meeting, but I'll be present in this. No problem. Okay.
Please, please. Oh, your Pradeep
May
Chaudhary. Uh, uh, Mr. Pradeep Chaudhary is also online. Your guru.
Hi,
Okay.
sir. How are you?
Your microphone is not working.
Hi, sir. How are you? Can you hear me now? All.
Mr. Pradeep Chaudhary, your speaker is not on.
Now it is on.
Now it is on. Now it is on.
Good afternoon, Mr. Balasubramaniam.
Okay.
Good afternoon, sir. Nice seeing you. Seeing all the colleagues. No, it's great.
All Nalco. Okay. So now it is 4 o'clock. Good morning, good afternoon, good evening, ladies and gentlemen. Today we have presentation by Mr. Balasubramaniam Venkatesan. So the presentation is on low amperage spot. He is having special things on low amperage spot, how he was running in Nalco. Whole world is going off for high amperage, but Mr. Balasubramaniam will tell his experience how to work with low amperage cell.
Because we are different. We are different. We don't fall in normal category, you know.
Okay. So anyway, he was. You
Eh,
know him. Many people know him quite well. I will just tell him that he was a director of production for 5 years in Nalco, and he was also director of finance and also functional director. And he had a long experience of working in smelters in Nalco. So we had. And now at present he has advisor SPG in AM Green India, who are setting up green alumina refinery with Rio Tinto in India. So is another interesting assignment for Mr. Balasubramaniam.
It's both alumina and aluminium.
Both alumina and aluminum. Of course, when you were director of production, you were looking after the complete value chain, start from bauxite to the metal. So anyway, we will first start his presentation, then there will be a question answer session, and there you can ask many questions to him. So over to Priyanka to start the recorded presentation.
Hi everyone, I am Balasubramaniam, former Director Production, Nalco, currently Advisor SPG in AM Green. AM Green has plans for putting up an aluminum smelter and an alumina refinery. I'm working here as an advisor for these projects based on my experience in Nalco. Smelter often faces a lot of power generation problems, due to which they are forced to operate at low amperage. This presentation aims at discussing various practical aspects of this particular low amperage port operations. We are having a captive power plant of 1200 megawatt capacity with 10 units of 120 megawatts each. 8 units are in continuous operation, giving power to the smelter. Out of the other two, one may be under annual maintenance, the other may be under periodic maintenance. We also have a coal supply agreement with MCL, which is a subsidiary of Coal India Limited. Often we face problems of coal supply from this Mahanadi coal fields, that is MCL. The reasons of shortage may be due to summer intense heat or monsoon or maybe the priority shifting to power utilities than to the industrial usage. Out of 8 units in operation, if one of the units go under major breakdown, which might take a longer time to get rectified, then we have problems in power generations. That means we are forced to operate at a lower input of power from the captive power plant. Another reason of low amperage is also when we are not able to generate due to water scarcity. The river source also caters to irrigation. When the state government prioritizes water supply to irrigation, then supply to power plant reduces. Another reason is ash disposal. After operation of nearly 3.5 decades, our ash pond was getting almost full, and we were finding it difficult to dispose the ash. Yes, we have developed or rather installed a lean slurry system which pumps the ash slurry to the nearby abandoned coal mines, but that took some time for us to commission it. So we often had problems with the ash disposal. Another rare reason could be anode or alumina availability. This doesn't occur normally, but when it occurs, the effect is the same. We got to curtail the production. Our pots normally operate at 182 kA with AP18 technology, but due to problems in power generation, we were often operating at a lower amperage, mostly around 160 kA. Now, this presentation will describe the various changes we adopted in the operations as well as in adjusting the various process parameters aiming at sustaining this low amperage operation for a longer period so that the whole pot line is not put into danger of a total shutdown. When the pots are in normal operation, we maintain 182 to 183 kA. Pot voltage is around 4.15 volts. We are installed graphitized bottom blocks with semi-graphite side blocks. We often achieve current efficiency 93.5 to 94.5 percentage. Production at 94.5% current efficiency is 1385 kg per pot per day. We maintain excess airlift-free target at 11.5%. Bath temperature is maintained between 955 and 960 degrees centigrade. We often operate at a 68 anode changing shift cycle. Very rarely we operate at 72 shift cycles also. And the instability or the noise is maintained at 0.16 micro ohms. Continuing the normal operating parameters, we evacuate 1.6 normal meter cube per second of gas from each pot. Number of alumina feeding shots for 1385 kg per pot day is around 2600 to 2700 in 24 hours, and each shot is 1 kg. Number of alumina feeders, we have four number of alumina feeders feeding 1 kg each at a particular time. We maintain 170 seconds of normal feeding interval and 100 seconds of fast feeding interval. Metal inventory, we maintain 11 to 12 metric tons and the metal height is 20 centimeter. Bath inventory is 8 to 9 metric tons and the bath height is 17 centimeter. Aim is to keep alumina concentration between 1.5 and 2%, and 4.5 centimeter is our anode cathode distance. What happens in the pot when the input power reduces? The thermal balance is badly affected. When the heat input reduces drastically, the liquid bath starts freezing. The side ledge will extend under the shadow of the anode. This will lead to increase in instability because of generation of horizontal currents. With this, alumina solubility also decreases and the alumina concentration goes beyond 4%. As you know, the parabolic alumina concentration versus resistance curve, when it crosses 3 to 4%, there is an increase in resistance of the pot. There, with the increase in bath resistance due to bath getting colder, the chemistry is also badly disturbed. The cathode gets cooler and the cathode drop increases. Similarly, anode gets cooler and the anode drop increases. And the net effect is there's an increase in metal level, which will be more dangerous as when the metal level is on the higher side, it would help dissipation of more heat, and that will further cool down the bath. The feeder holes getting choked, and this will lead to more anode effects. Ultimately, the major risk is anode surface leaving the contact with bath. That means open circuit. We should not allow all these things to happen. That is our main objective and aim. We will be taking actions to mitigate all the effects described in this slide. The effect of low amperage and its manifestation is briefly cathode resistance increase, anode resistance increase, bath resistance increase, and the pot temperature reduces. All these enhanced drops need to be compensated by way of increase in voltage or the set point resistance. So we had to increase the anode cathode distance to negate the effects of all the above. Now, by doing this, the main aim is to add heat to the pot to the extent possible and at the same time try to retain that heat in the pot. That is the ultimate aim. We know what is the problem, we know what are all its effects, and we know what are all its manifestation is going to be. Now, how to tackle this problem? First of all, immediately, we should always aim to retain as much heat as possible and try to infuse some heat as far as possible. This is the crux of all the actions we are going to take. First, suspend anode changing operation. Anode changing operation takes away heat by way of taking out the butt, hot butt. When the hot bath is taken out, some of the heat goes away along with that. And when we skim the pot cavity, anode cavity, we also take out some of the bath along with that. That means a hot bath is also being taken out. By that, we lose heat. And the third and the most important thing is we are going to add a cold new anode, which is going to absorb heat, which is going to take away heat from the present heat which is available. So, because you see, the new anode will not take current immediately. So, initially, it starts taking heat from the bath which is already there. That means cooling it down to some extent. So, if we suspend anode changing operation, there is a chance we may retain some heat. Now, next, concentrate on the anode covering. Wherever covering is left pending, do carry out the anode covering immediately and start anode dressing activities. This will help us to retain the heat. As I told you in my earlier slide, from each pot we evacuate 1.6 normal meter cube per second of gas under normal circumstances. That means at say 182 kA. Along with this gas, heat is also going out. So at at the reduced amperage, we need not evacuate that amount of gas which we were evacuating at normal amperage. So reduce one exhaust fan at FTP. Normally, four fans are in operation in fume treatment plant. Cut off one fan so that eventually you will be taking out only 75% of the hot gases compared to normal operation. This will help us to retain heat and not to lose heat by way of gas evacuation. Now, most important thing is how to add heat. We can add heat by increasing the pot voltage. When the amperage goes down, along with that, the voltage also goes down. So, in order to step up the heat input, we need to add more resistance and take up the pot voltage to at least 4 or more, minimum 4 or more than 4, whatever possible, up to whatever it is possible. When the amperage goes down, the pot voltage goes down to nearly 3.2 to 3.3, which left like that will give all negative effects. So try and increase the voltage up to 4 minimum. This will help us to add heat because heat in joules is I squared R. So increasing R will help you to put in more heat to the pot. Temporarily stop alumina feeders because already the pot has some alumina concentration and we have reduced the amperage. Temporarily stop the alumina feeders. Let the alumina, which is already in the pot, let it get consumed so that no sludge formation would be there. And later we can adjust the alumina feed rate according to the amperage. Increase the alumina feeding durations, both normal as well as fast feeding, as per the production expected, which I will explain later. Suspend ALF recharging immediately. We know very well ALF free helps us to keep the bath in liquid state at a lower temperature. But at already reduced amperage, that ALF3 might have a negative effect if we keep on adding. So temporarily stop it. And later I will explain what to do with the target ALF3. Now, start tapping metal from the pot, extra tapping. Normally, if we keep 20 centimeter, try and evacuate more metal from the pot so that lesser the pot in metal inventory in the pot, lesser the heat dissipation would be there. This will help us to retain heat. The Identify low bath pots and take appropriate actions. Increase the bath height measurement frequency. We normally use alumina mix in the crush bath for anode cover. Normally we use 30% alumina in the mix. Reduce that to 10% because we don't need alumina now. We need only bath to be added to pot and not more and more alumina. So from 30%, bring it down to 10% in the anode cover mix. This will help us to try and infuse some bath and reduce alumina content in the pot. ALF3. Reduce the ALF3 target from 11.5% to 10%. At reduced amperage and with this size of pot, we need not operate at 11.5. We need to bring it down further to suit that low amperage. By our trial and error method, we found out that 10% target is the best suited for our operation. So we settled at 10% excess ALF3 target. With 10%, we could have enough liquid bath inventory in the pot as well as the temperature was maintained around 945 to 950, which is the best we could hope for. We normally we could maintain 950 plus or minus 2 degrees centigrade. Increase the bath temperature measurement frequency. Take corrective action on low temperature pots. Leave the pot regulation to do its job, like maintaining the pot voltage, maintaining the alumina feed rate, and other normal pot regulation job. Let the pot regulation system carry out. Now we will discuss about anode changing shift cycle. Under reduced amperage, we need to change the anode changing shift cycle because the anode would not be consumed at the same rate as it was being consumed at 182 kA. Now that the amperage has reduced to 160 kA, there is a necessity to increase the shift cycle. So under normal circumstances, the anode consumption is 0.5 centimeter per shift. So out of total height of 550 centimeter, roughly 34 centimeter is consumed in 68 shift cycle, leaving around 20 centimeter butt height. This was the reference we took to achieve. That means to what extent we can defer the anode changing and increase the anode changing cycle so as to achieve around 20 centimeter butt height. So with this objective, we started at 76 shift cycle. From 68 shift cycle, original cycle, we stepped it up to 76 shift cycle. With that, the butt height came to 22 centimeters, still 2 centimeter more than our target. Hence, we switched to 80 shift cycle. After operating 80 shift cycle, the butt height achieved was around 20 centimeter. So we settled at 80 shift cycles for anode changing at 160 kA operation. And this gave the desired results and maintained also the other parameters of the pot as it should be at 160 kA. Yes, as a precaution, we discontinued slotting of anodes. There's no particular reason for this, but just to have enough mass in the anode so that it will help us to increase the shift cycle. The alumina requirement drastically reduces at low amperage because the production is is only to that extent of 160 kA and it doesn't require that amount of alumina which we were feeding at 182 kA. The only challenge here was to what should be the current efficiency we should take for the calculation of alumina requirement. We started at 94% current efficiency and calculated what would be the metal production at 94% current efficiency and 160 kA. The metal production is 12 kg per pot per day, which required 2327 kg of alumina. That means we need 2327 shots of alumina of 1 kg each. So with this, we fixed our normal and fast feeding rates, and it worked well, and it helped us to sustain the pot operation. So this was the methodology we used for fixing the alumina feeding intervals and allowed the pot regulation to do the rest. How to fix the target XSA lift rate? At 182 kA, we used to operate at 11.5% XSA lift rate target. With amperage reduced to 160 kA, it is not appropriate to maintain the same target for literally two reasons. When the amperage is less, the heat input is less. At the same time, having more airlift rate in the bath would increase the bath resistance and the bath density, which we at any cost we wanted to avoid. So to avoid increase in bath density as well as the bath resistance due to excess airlift rate, we thought of reducing the target. Initially, we started with 11%, and later we found the temperature was not really settling at the required 950 degrees we wanted. So we went further down from 11 to 10. At 10, the we could maintain not only the bath level, the inventory, we could also maintain the temperature. And the other parameters like resistance and all could be maintained within the desired range. Hence, we fixed 10% as target for 160 kA operation. Additions of ALF3 was managed accordingly. I mean, you know that extra hopper is there in the twin hopper, and we adjusted the ALF3 feeding intervals accordingly. Coming to extra metal tapping. When the amperage reduces, we need not have the same metal inventory what we used to have at 182 kA. Having more metal inventory in the pot would lead to extra heat dissipation, and that will cool down the pot further. With this in mind, at the reduced amperage, we thought it is appropriate to lessen the metal inventory from the pots. So we started tapping additional metal from each pot so as to lessen the inventory as well as the metal height. When no, at 182 K, we used to have 10 to 11 ton of metal as inventory and metal height as 20 centimeters. We gradually brought it down to 17, 18 centimeter, and the inventory was around 8 to 9 tons. We reduced literally 2 tons from each pot so that we could maintain the bath temperature of 950 degrees centigrade. And this reduction of metal inventory really helped us to sustain the operation. By systematic implementation of all the various changes, we could achieve a stability in around 12 to 15 shifts. That is, around 4 to 5 days, we could gain full stability of pot operation. And later on, close monitoring allowed us to literally continue this operation for nearly months together. At a, at one particular time, we could operate for nearly 4 months continuously on this low amperage. And the parameters achieved was really good, very comparable to our 182 kA operation. Current efficiency improved to 95%. Pots were rock stable at 0.15 microohms. Metal purity improved and it was well maintained. It touched 99.8 compared to 99.7275 normally we used to achieve. DC energy consumption reduced by 10%, and literally no anode care was required. It was a successful, experiment. Definitely, the power situation would improve. So, on getting the information about power availability, what should be our strategy to restore original operating amperage. This strategy we're going to discuss in the next two slides. Amperage stepping up is always done in an incremental way. We increase only 2 to 3 kA at a time and wait for at least 4 shifts for the next increase. In the meantime, keep close watch on bath temperature and the bath level. Earlier, we tapped extra metal so that the lesser metal level would allow us to retain the heat. Whereas now, when we are stepping up the amperage, we need to allow the metal to build up in the pot. Tap lesser metal or totally skip metal tapping in order to get the original metal inventory as well as the metal level. Now, now coming to voltage. Earlier, we increased the set point resistance to maintain the pot voltage at around 4 volts. Now, when we are stepping up the amperage, we need to reduce that set point resistance gradually so that we maintain around 4.1 volts initially and gradually to 4.15 volt. All these actions may take around 12 to 16 shifts to stabilize. After that, you will see a normal, smooth operations going on. Now, coming to alumina fading, we do not have a particular current efficiency to set the shots or the intervals. Now we need to adjust the alumina fading as per the amperage and the slopes which your pot regulation system gives you. Now accordingly adjust the fading intervals to avoid anode effects as well as steep variations in slopes. Earlier, we increased our anode changing shift cycles from 68 to 80. Now, for stepping up the amperage, we need to gradually reduce this anode changing shift cycle from 80 and slowly get back to the original 68 shift cycle. For every 5K increase in amperage, the shift cycle was reduced by 4 shifts. That means we had initially 80, then we went to 76, 72, and then finally to 68. Now, coming to ALF3 target, we reduced it from 11.5% to 10%. Now, while increasing the amperage, we stepped up 0.5% at an interval of 4 shifts to reach the original target of 11.5. This helped us to gradually restore the bath chemistry. You know, you remember that we reduced the gas suction, that means the evacuation of gas from the pots by stopping one fan in FTP. Now, based on the bath temperature and the bath levels, we may increase the suction slowly by operating the exhaust fan, which we stopped earlier. We can throttle the exhaust fan to the extent based on our bath temperature mainly. All the above actions will help us to stabilize and get to the normal amperage and operations in about 10 days time. After which everything will fall in place and we can continue without any problem. Well, finally, we can restore the crush bath alumina mixed to 30%. You remember earlier we reduced it to 10% in order to feed less alumina at low amperage as well as to feed more bath. With all the aforesaid procedure and methodology, we could successfully tackle the low amperage situation. Not only that, we could also lay down a well documented procedure for future occurrences also. Yes, we don't want this kind of situations, but in any case it happens, we have a well documented procedure to follow. Another important lesson what we learned was that anything less than 160 kA was found to be disastrous. At 150 kA, the batch shrinkage was so rapid from the third day and it was literally uncontrollable. So anything less than 160 kA is not considered safe. Some important decisions were taken. Number one, not to operate lesser than 160 kA. Number two, to import power to an extent to maintain 170 kA. You know, importing power, having a captive power plant is considered as a sin because the economics would not work out. You may be importing at the rate of around rupees 6 per unit compared to when we generate, which is around rupees 3 per unit. However, to tackle this low amperage situation and to save the pot line from ultimate closure, it was decided to import power so that we can maintain at least 170 kA. Since this kind of either reduction or fluctuation in amperage is faced by almost all the smelters, both AP and GAMI are carrying out research for incorporating a suitable program in the pot regulation system itself. All the actions described in this presentation would be most probably incorporated in the regulation program itself. That means we would be having a robust system to tackle this kind of problem. That brings us to the end of this presentation. I thank you all for your patient listening. Thank you very much.
Thanks, Mr. Balasubramaniam, for your excellent presentation.
Thank you very much.
And I can see in the list there is a Professor Kawande is there in the one of the listener. And
Yeah,
Mr.
he's a great aluminum
Yes.
technologist. Yes.
Yes, Professor Kawande is there. And Mark Dupis is there. So welcome,
Great.
Mark Dupis. And also Dr. Amit Gupta, our from Nalco R&D Center.
My special
ABS-CLC.
thanks to them.
Yes. So, Professor Kawande or Mr. Dupis, if you have any comments, please come forward and please ask question to Mr. Balasubramaniam. Professor Kawande. Okay, the session is open for discussion. Please go ahead and ask question to Mr. Balasubramaniam.
Yeah, Ashokji, I'm Sashi Kumar from Mahan Aluminium.
Yeah, excellent.
Yeah.
I know you.
Yeah, right. So one question is from my side is like there are two concepts which normally goes like whenever there is a power reduction, we also try to keep the voltage minimum because we can push more amperage in the lines so that H equal to I square R. So we can put more heat into the system so that the temperatures can be maintained a little bit more. And there is one more school of thought is to increase the voltage and keep the current little so that we can also put. So which is the option and we should choose and when to choose which option, whether H equal to I square or whether we should increase resistance or we should increase current by keeping the lower resistance.
Look, it depends on the situation which you are in. If there is a problem with the power availability itself, then you will have to choose the increase in resistance. At least because when the power input is not there, you have to raise the voltage to the extent possible. And if you don't have any power problem, power availability is there, yes, you can step up the amperage to the extent your pot can take. That means when you step up, at the same time you will be the temperature, the bath enthalpy increases, for which you will have to reduce the ACD to compensate that. Whether have a close watch on the instability, how exactly it behaves. To that, till it is stable, till the pots are stable, you can go ahead with that particular exercise of reducing the resistance. The thing is, the noise factor is the main guiding point here.
Okay. I think, and one more thing is that whatever the, as you said, 10% reduction or 5% reduction, I think we should build up into the algorithms itself. So
yes. Now, both GAME and AP, they are working on that. Soon they will come up with this particular regulation system. Yes, this is required for the aluminum industry. They are working on that.
okay, thank you.
Good question. Yeah, please. Any more questions?
Mr. Balasubramaniam Bhatta speaking.
Yeah, welcome, but after a long time.
After a long time. Actually,
Yeah, you can see me. We all did together this one. Yes.
I was there associated with this also, but this has helped in next power failures in Portland 4. And also the latest was 2020 1st October when we had
yes, we had a severe problem in CPP.
Zero in a 48-hour span.
Yes. This kind.
One question was there whether pot life will be affected by this. This question actually.
Yes, this definitely affects the pot life. To the, there will be a reduction of at least around 5% because the kind of thermal shock you are giving to the pot, to the cathode, is definitely not good. Yes, we need to avoid this kind of situation. If at all it occurs, yes, we face the consequence also. There will be a problem with the pot life. Yes.
Very good. Okay. So Professor Kawande is there online. So
can you hear me?
Yes, I can hear you. Please carry on.
Okay, very good. Let me first give the compliment to the presenter. It was a very, very interesting presentation. Very well organized.
Thank you.
I have one question, if I can ask about anode effects. Did you see any changes there, increase in the number of anode effects and the duration of it?
Yes, we saw an increase in anode effect initially till we arrived at that particular, feeding intervals. It took some time for us to fix the feeding interval because we were not aware of what is going to be the efficiency. So it was a trial and error method where we could reach at 94% as our reference for fixing the alumina feed intervals. Till such time, we had some problem with the anode effect. Yes, you're right.
Can you tell me how much, how frequent was, what was the anode effect frequency before and after?
Before the problem started, the anode effect frequency was around zero point 0.3, zero point 0.4. During the stabilization period, it went up to 0.7, 0.8.
Do you have, I guess you feel the same requirements as everyone else to reduce the anode effect emissions?
Yes, it is required because the anode effect at this kind of disturbed current situation is also not good, because the squelching procedure may not be really good to tackle that, and if you have more number of anode effects, it's a hell of a problem to tackle that,
Yeah.
Yes, earlier we arrive at that correct feed interval, better it is.
Yeah, that's good. Thank you.
Thank you, sir.
Mr. Balu, that what life I was telling,
Yeah.
actually afterwards we have seen in Portland 2 average life did not reduce, rather it increased.
Yeah. Look.
Nalco became
Maybe
in the world highest spotlight. Nalco is the highest spotlight in the world.
Maybe that is one of whether I can, whether you take it as a compliment or I don't know. Because thermal shocks really don't do.
Side ledge was thickening, so side ledge that has helped their life. I think so. And side ledge had thickened.
Maybe, theoretically you are right, but thermal shock practically they do not do anything good for the life. Okay.
Yes. Thank you. Very good presentation.
Okay. Mr. Mantha.
Good afternoon, Balasubramaniam sir. It's a nice presentation.
Thank you.
Just want to ask you just two minor doubts. So you said the anode cover mix.
Yes.
You have lost the alumina percentage from 30%, which is normal, to the 10% during this
yes.
period. But it will also reduce our top insulation, so cooling would also happen from there. So why the decision of reducing?
You're right, because you in my presentation I also said you must step up your anode dressing. Okay, yes. The anode dressing is very vital during this kind of troubled operations. Apart from just reducing to 10% alone will not help. As you rightly said, the permeability will increase because of the grain size. Then you will have to concentrate or do more anode dressing. Don't leave the anode exposed.
Yeah, but say like normally we keep, say, 10 centimeter of cover height. So you have any particular target? It should go from 10 to 12 centimeters.
No, we to be honest, we didn't. We didn't approach it that way. But we saw that the anode is well covered and not left. It is not left open to air oxidation. That's what we concentrated on. Repeated anode dressing. That's what, because we concentrated on the practical aspects. And this one is, we thought we got to intensify our anode dressing activities. That's what we did.
And one more thing, we don't have any provision to run the pot line with 72 shift cycle in a normal operation at 180 to 183 kilograms. Because you are saying 68 means you will have one extra anode setting each cycle.
No, you are right, because it all depends on what kind of CP coke you literally get and how good your anode in terms of weight. If the anode weight is good, then you are blessed. Otherwise, you are in deep soup.
No, I'm coming from the point of, if it logistics permit, like our kiln pits and other crane clearance, everything. If I understand. Height of anode is increased from 550 to say 570, 20 centimeters, and a 20 millimeter increase it. Definitely that will ask for 4 shift extra.
Yes, but provided, as you said, your port architecture allows that.
Yes, sir.
Plus, you should have those modifications done in GAP and also in your.
Big oven, yes.
It's a
Guarding,
big.
yes.
Yes. It's a big modification we are talking about. Yes. These things have to be done. It will help you in increasing the amperage also if you can do that.
Yes, that's true. Then one more thing you said, initially when we reduce the amperage by 20 kV, whatever is the amount, you said you will stop the feedings. How long you're stopping the feeding?
It was only temporary stop. Actually, the regulation will take care of switching on the feeders as per the requirement. Okay. So when you just temporarily stop the feeders, the regulation will itself monitor that and switch it on as and when required. But okay, but the thing is, this will lead to anode effects also. At the same time, quicker you reach your feed interval destination, that is better.
And more than this anode effects, I mean, anode effects is definitely a concern in the present days. Your maximum voltage the line can operate at wouldn't be exceeded by the power station, won't have trouble in maintaining the line voltage. If this anode will further increase and you were already increasing amperage because of low voltage because of low amperage.
No, our substation is having enough that leverage for tackling this kind of things also. We didn't face that problem. All the substations are, tailored for this particular situation also.
Generally, my experience says that because of this we have a limitation. Maximum line voltage cannot go beyond X volts.
Yeah, theoretically you're right. Yeah. We always keep 20 to 25% extra with our regulation transformer, so that this situation is tackled.
Yeah. Thank you, sir. Thank you very much.
Welcome.
Yeah, Mr. Pradeep Chaudhary can ask question.
Yes, sir. My guru.
I must first, Mr. Balasubramaniam, I have the privilege of calling you Balu. Don't mind. Huh?
Sure. Please carry on.
So, really, very, very excellent presentation. I always told everybody that if there is an expert on port lines, that's Mr. Balasubramaniam. I have always maintained you as one of the best experts on port line in the whole of India.
Thanks for the confidence you have in me.
And we have been the partners in this crime. What we made.
You saw these things happen. Huh?
I saw, and I sometimes closed my eyes also because the way we were proceeding.
It was a team effort. Literally, everyone played a role in that, and all the inputs from all the. Yes.
Actually, it defied common sense because aluminum Pessina was so much, or RTA, whatever you say, they were so much against.
They surrendered.
They said no one can operate port at 160 kiloampere. And Mr. Balu and his team, and I being supporting him or somebody else supporting him, we just did this, and that's wonderful. And afterwards, AP was also surprised that how could this happen? Have all these things.
And now they are building this logic in their regulation.
They have taken it very long. Actually, they should have done it earlier.
Much earlier. Yes.
I will add one more thing, Mr. Balu, that I am after this digitalization, and this is also going to give its beat into this process. This 160 kiloampere.
Yes.
Digitalization will have a preemptive indication and predictive things also. So I think this can help add something to this type of.
Sure. I have seen this AP guys giving this kind of presentation. They call it flexible power. Strange name they have given for that, but it was not really impressive, and they could not really explain many things.
No, wonderful, and actually it was so nice to see everything presented by you, bit by bit, and what you did. Actually, what it was done there, we saw it, but when you put it on the paper, on that presentation, it was really wonderful. And I must compliment you again and wish you all the best. Please
Thank
carry
you,
on your
sir.
work. Please carry on your work for the smelter.
Thank you.
Really.
Thank you. Thank you.
Mr. Behra, please.
Yeah. Mr. Subramaniam, it is really nice presentation, but it was so fundamental and so basic things were told or explained. Will it be helpful for this advanced sports of 490 or 500 kilo ampere?
Yes, the same technique can be applied to 400, also 500, provided your amperage is 10 to 12% fluctuation is there. Till that, it is okay.
Because nowadays all pots are operating at a
Yes,
high.
yes. Well, I have taken up this particular thing with all the technology providers,
Yeah.
and they're I mean almost same thing, 10 to 12%. I mean they are building up this kind of program in the regulation.
Okay, that. Actually, that should be message to all people because
Yes, yes, because I am engaged with the latest technology as well as with the in discussions with them. They are this is the baseline they are fixed 10 to 12%. They are going to incorporate that in the regulation system itself.
Thank you.
Welcome.
Yeah, I missed your transport because I was going behind you in a motorcycle. That was forgotten. Thank you. Thank
Okay.
you.
Please, any more questions?
And I'll just ask something, tell something. So I request Mr. Balu to be very much active in our IBAAS conference. That is my
Yes.
request. My request.
Sure, sure, sure,
But
sure.
all this what we have done for the Nalco pot lines, they need to be exposed to the entire world actually, because I believe
Sure.
that there are path-breaking things we have done in those time. In that time, I'm telling you, long back, so many years back, maybe 25 years back. So
Yes,
I
yes.
think
This is just a practical paper, and it is not the database or data analysis or research type of thing. It is what we did practically on the shop floor. That's what I have presented.
anyway, you join IBAAS definitely.
Yeah,
That is
sure,
our
sir.
request.
Welcome.
Thanks.
I like it. Thank you very much.
Thank you very much.
Yes,
Thanks all.
we have another lecture series in February open. If anybody is interested among you to deliver a online presentation like Mr. Mantha Lakshman Murthy or somebody who is interested, please come ahead, go ahead and indicate whether you can make a presentation on last Friday of the February. That is
Yeah.
almost 28th February. So anybody is interested? So
Yeah,
please.
I will write to you.
Okay, Mr. Behra, please provide your topic and we will organize your presentation at the end of February.
Sure.
Maybe your present paper which you are giving for IBAAS conference may be suitable because it discusses from bauxite up to the value chain and complete up to the smelter and downstream. Will you like to present that paper here in the end of February?
Yeah, that I can present, or I will present on maintenance of green anode plant with worldwide maintenance. So that practice I will tell it to all audience, to factory people.
So please send your topic, and IBAAS office will give you wide publicity of your work. And anybody else for the March, April, we have a whole year program every month. At Friday of every month, at the end of month, we make this online presentation. So, Mr. Mantha, if you want, you can also please send your topic. And a smelter is always welcome because our next conference will be in Jharsuguda, which is the hub of Indian smelters.
Yeah, I'll come back to you, sir.
Please come back. And anybody else who is interested, Mark Dupis, I'm not seeing you. Where are you? Mark Dupis, please put on your sound system. Mark? Okay, Mark is not listening or he has kept it somewhere. So anybody else is interested for making a lecture on this lecture series of IBAAS, you are all welcome.
One of the months I can make it actually. As well.
Okay, Pradeep Chaudhary, please
Yeah,
send your topic.
one of the months. Let it be March, something like that. March or April.
Okay, please. So, and Bharat Vide, Mr. Bharat Vide, are you interested?
Yeah, I will attend.
No, not attend, making presentation.
No.
Okay.
I will not be able.
I think Devanand Bhattacharya can give, I believe.
Bhatta
should give.
I'll give in the IBAAS, huh?
Okay.
No, but we one more here. IBAAS is far off now, September. So give one more. Yeah.
If you have anything planned, please let me know. Let us know.
Okay, I'll let you know.
Please, Bhattacharya, Devanand Bhattacharya, please. You were always coming in IBAAS conference. Anybody else?
SN Das can give. He has a good.
SN Das, SN Das also. Welcome.
He has got something good on green aluminum and all this. He has been working.
So okay, sure. We'll talk to Mr. Das also. Okay.
So, good. Thank you all. Thank you all.
Yeah.
Thank you.
Good. You are at the end of the end of this presentation.
I thought it was 6:30 was the beginning of the presentation.
No. 4 o'clock Indian time. I don't know what's the time in USA that time. 4 p.m.
9.5 hours earlier.
Anyway. So thanks again, Mr. Balasubramaniam, and we would like to see you active in IBAAS. And please tell us more about this company, if possible, about AM Green. AM Green, what is their plan in India?
Okay, I will do that. When I come to IBAAS, sure.
Okay.
Thank you all.
Thank you all. Thanks to everybody.
Thanks
everybody.
Thanks.
Thank you. Good evening.
Bye.
Thanks.
Bye.
4 o'clock is 6:30.